Next two question, number 3 and number 4, right? Yeah. So let's look at the number 3 first. Given a computing problem, if you have an algorithm to solve it and nobody in the world can improve it anymore, then you can say that your algorithm is optimal. First, the statement is false, but let me explain why. Here, in my description, in my statement, in the way I write this statement, I try to confuse you, I try to mislead you, go to the wrong direction, and check you if you really understand that optimality concept. Under what situation we can say an algorithm is optimal? Here, I give you a description, the key part of the sentence. Nobody in the world can improve this algorithm anymore. But still, here I like to say, even here, still not strong enough. Not strong enough to say this algorithm is optimal. Here I try to make you feel it is very strong to give you the information that it is optimal. How strong it is, nobody in the world can improve it anymore. Right? It looks strong, but actually still not strong enough. Why? Nobody in the world. That means we mean the current time, right? We're talking about the current time, right? Everybody in the world, the living person, right? Each living person in the world currently, right? We're talking about people who are living right now in the world, right? Although so many people, but we just talk about current living people in the world. Think about the situation. Nobody in the world can improve it. How about after 200 years, someone can improve it? Right? Is it possible? It's possible. After 200 years, because our current people in the world still not smart enough. We cannot say, after many generations, the future peoples are not smarter than us, right? Nobody can say that. Future people, so definitely, in general, future people should be smarter than us because they inherit the knowledge we developed, but they can further develop new knowledge, new methods, new techniques. We do not know, right? Yes. So, and there are so many examples. There is one famous example called Fermat's last theorem. Have you heard of that? A very famous story called Fermat's last theorem. Okay, yeah. This theorem was solved after, more than 300 years. Solved after 300 years when it is raised. Okay, yeah. For Mar, it's a conjecture. At that time, it's a conjecture. Yeah. So, and it was solved in 1995. Yeah, completely solved. The first time, 1993, that professor solved it, but there was a big mistake. Yeah. Then after 2 years, he fixed it. So we say officially, it was solved in 1995. Yeah. So in this example, it tells us if people in the world cannot solve one particular problem, still there is a chance that future people can solve it, okay? Can do much better. Yeah. So that is one angle to look at this statement. Why we say, so this statement still not strong enough to claim that this algorithm is optimal. Okay, yeah. But another related question, how do you claim that one particular algorithm is optimal? That's what we did in our finding the minimum question in our class. We use some convincing argument to show our algorithm is optimal by one method. By what? By finding a critical property. Okay, that way, finding a critical property, then we use this property, we can show no other algorithms can do better than our current one. Okay, so the one we use n-1 comparisons. Okay, yeah. For finding the minimum. All right, yeah. So that's a good example to show how to really prove our solution is optimal, because we showed nobody can use n-2 comparisons to find a minimum. Nobody can use n-2 comparisons. Even after 200 years, 2,000 years, nobody can use n-2 comparisons forever. Yeah. Our proof, yeah, we need to make sure our proof is correct. Okay. If our proof is correct, then nobody in the future, nobody can do better than our current solution. That's what we need for the optimality. That's the way we can claim our algorithm is optimal. All right, yeah. But the current statement in question number 3, that's not strong enough. Okay, so we cannot claim. Yeah, but here you can see if you answer this question just by your intuition, it may not be reliable. All right, because people can get misled easily. Yeah, because when you get some information, it looks strong, but actually still not strong enough. Yeah. All right, so that's question number 3. Yeah. Question number 4. All right. When we apply the greedy algorithm to solve computing problems, do we always get optimal solution? Answer no. Because the greedy algorithm, remember we have some discussion about greedy algorithm. We apply the greedy strategy. The greedy strategy locally. Yeah. The reason why we apply locally, because easier to do, easier. All right, easier, not globally. Okay, not globally. Okay, globally, then you have a chance to be optimal. Okay, globally optimal. Locally, the best choice may not lead to global optimal solution. Yeah, not globally. Why? Too hard. Too hard. Yeah. Okay. Yeah. Yeah. So that's the point. Yeah. The greedy strategy, that's the point. Some relatively easy way to solve a problem with some solution, and sometimes it's optimal, sometimes it's not. Okay, yeah. So here, 2 cases. Yeah. Optimal, if you are very lucky, then it's optimal. Okay, but in general, not optimal. Okay, yeah. Actually, most of the time, not optimal. But even not optimal, we do not say it's useless. Okay, we do not say it's useless. Not optimal, but if close to optimal, slightly worse than optimal, still a good solution. All right, if it's close to optimal, yeah, very close, okay, still it's a good solution. Yeah. All right, yeah. So that's the value of greedy algorithms. You know, its value. All right, yeah. All right, so that's these 2 questions.